Okay, with this question, it seems to be a force question, but in fact, it's purely a conservation of energy problem. So what we have here is we have a ramp, and the ramp is 3 meters high, and it is 5 meters long. So that's 5 meters. Now they give us a coefficient of friction, but you will see that we don't actually need that. That's a red herring. It's a piece of information that is not necessary. Okay, so what else are we given? Well, we know the mass of this particular object is 30 kilograms. And we also know, or we assume, that the initial velocity at the top of the ramp is equal to 0. So that this will be position 1. At position 2, which is at the bottom of the ramp, we have a speedometer that tells us that the speed is 5 meters per second. So we'll use conservation of energy. So using conservation of energy, what we're going to do is we're going to compare the two total energies at the top and the bottom. And because friction is involved, we are going to assume that they're going to be different. So the energy total at the top here and the energy total at the bottom are going to be, this one in particular is going to be smaller than this one, and that's because some of the energy is going to be lost due to heat. So whenever there's friction involved, that always involves a loss of heat energy to our system. So conservation of energy. So the total energy at the top so ET1 is equal to ET2 minus some energy that is lost due to heat. And maybe we'll even call it heat loss. We'll call it heat energy here. So EH. Okay, so ET1 is just potential energy. So that's mg delta H. And that's equal to the kinetic energy down here. So this is half mv2 squared. And then we have, actually this should be a plus, because if this is bigger than this, then we need to add the loss energy to make them equal to each other. So this will be plus EH. And then we know that the mass is 30 times 9.8. And delta H is equal to 3, equals half times 30. And V squared, that's 25, plus EH. And when you rearrange that and solve for EH, you get 507 joules. Now, this is the energy lost due to heat, but it's also the work done by friction. So the work done by friction is equal to the change in energy lost by heat. Well, these numbers are the same. So another way that we can express work is using force times displacement. And we know that the particular force that we're interested in is friction. So this is actually what we want to find, this value right there. So we know the delta D, the force happened along the ramp itself. So the displacement is 5. So F is equal to 507 divided by 5. And this works out to be 101 newtons. So FF average. So therefore, the average force of friction is 101 newtons down the ramp. Down